Hello and welcome to Technical Utkranti. Let's have a look at the thought for the day. So today we would be looking into the 13th question on linked list. So let's see what the question is. Here we will see how to flatten the linked list. We are given 2D linked list with child and next nodes. We have to convert it to a 1D linked list with only child nodes. We are given that the child nodes of the linked list are in the ascending order, as you can see in this diagram. 1 2 are in ascending order, 5 and 9 is in ascending order, and 158 makes the main trunk of the linked list. This may or may not be in ascending order. The final flattened linked list should be in ascending order like this. Before looking at the solution of this question, here are two hints if you want to try it on your own. Merge the linked lists verticals starting from the last two verticals. So this and this are the last two verticals. Start by merging them. And then once these are merged, then this merged vertical should be merged with the previous vertical. And ultimately, this would result in a flattened linked list. When we start something from the end, we take help of recursion. So that is the second hint. The link to the question is available in the description of this video. Do spend some time on it before seeing the solution. Let's look at the approach. We start by attempting to merge the last two verticals. So here I have shown you the last two verticals. Merging is to be done in a merge sort way. The exact details will be evident once we see the code. We need to create the dummy pointer, which will be storing the merged linked list obtained from merging the two verticals. There is another pointer which is the reference pointer to the dummy node, and this is required in order to store the position of the first node because dummy will keep on changing. Let's see what I mean. So firstly what will happen is this linked list, the first nodes of these two linked lists would be compared and the smaller one will become dummy. So dummy would be 5. So it would be like dummy dot next would be 5, and then dummy is equals to dummy dot next. So dummy becomes this node. Then the comparison would be done between 9 and 8. So 8 is smaller than 9. So we will have next child as 8 and dummy would become 8. Similarly, then 9 will come and dummy will become 9. Since dummy has come till here in the process, that's why we had to keep the reference pointer. And once the two verticals are merged, we would be returning the reference dot child, which would be pointing to the to this particular node. Similarly, this 589 would then be attempted to merge with 1 2, which was to the left of this particular vertical. Here I have created this double node class, which will be having two neighbor nodes, which is next and child node. Then I have created three nodes, 1 5 8 in the main trunk, and first node has a child of 2 and the second node has a child of 9. So what I am doing in flattened linked list is firstly I am trying to go till the end of the linked list. So this recursive approach would give me head as the second last node and head dot next as the last node of the linked list. Then I will be doing the merge, the vertical merge which I showed in the approach. Now let's look at what the merge is. There we created one dummy node. Here I have indicated it with 10 and a reference node which will be pointing to the dummy node. Now this is the merge sort technique. This technique has been used at multiple instances in the solutions that I've illustrated previously also in this series. And finally, we return the merged linked list. So this merged linked list becomes the head of the linked list, which was, so these head and head dot next were merged to make the head. In this way, we would be merging the entire linked list in a recursive fashion. So let's look what we get. So here I've already printed it. Earlier it was only printing the trunk nodes of the linked list, and then after merge I am getting 1 2 5 8 9, because 2 was the child of 1, 8 was the 9 was the child of 5. So after merging in the ascending order, it would be 1 2 5 8 9. So I hope you understood the solution, the approach, and do try it for yourself, because this was a bit sophisticated problem, and unless you solve it yourself, uh, you'll not remember the solution. So do try it for yourself.